Everyone, welcome back to my channel. And in this video, we are going to discuss. Here I'm just only going to mention the important questions. I'm not going to explain the topics. Okay, as exam is tomorrow, and you should know which are the important questions. Just note it down. And also in my this PPTs, I have mentioned the points also, like what answer you should write for that specific topic, so you can just remember that at least during your revision time, and it will be very easy for you to write down in the exam. Okay, so before wasting any time, let's get started. So this is the module 5 important question PYQs. Okay, so let's discuss. So here it is again divided into two chapters. One is artificial neural networks and second is clustering algorithms. So in this artificial neural networks, you have biological neuron and artificial neuron. Then comes perceptron and learning theory. Then types of ENN and applications, and then advantages, disadvantages, or you can say limitations and challenges. Whereas in clustering algorithms, you have clustering approaches and proximity measures, hierarchical clustering algorithms, partitional clustering algorithm, and density based and grid based method. Okay, so the next is expected. Okay, most important for module 5. Okay, these are very important. Okay, do not skip this questions. Okay, so 99% of asking these questions based on theory, okay, which can be asked for 10 marks. So here is the tip, okay, or you can say the method or the approach to write the answers for the theory question. So you can start with definition, diagram. If it consists algorithm, write down the algorithm, and obviously it is a machine learning subject, means it will be algorithm based. Okay, so the concept whichever you learn here, it will be algorithm based. Okay, machine learning model, the algorithm how it works, that you have to write, and then followed by the advantages and limitations, and plus you can give the limit real time examples for that. Okay, so the first question is explain ANN with biological neuron and artificial neuron diagram. Okay, so here I've just shared the questions. In the next slide, I will tell you, okay, for this specific question, what actually should be there in that answer. Okay, and next is explain perceptron model and learning rule. Third is discuss types, application, advantages, and disadvantages of the ENN. And then comes the clustering questions, okay, which is explain clustering approaches and proximity measures. So I'll not read out the questions here. I'll just move to the next slide where I'll tell you for this question what answers you should write. Okay, what actual keyword should be mentioned in the specific question. Okay, so yeah, so this is the first one where where it is asked about artificial neural networks, or they can say ANN. So you have to write the definition. So what is the definition? ANN is a computational model inspired by the human brain. It learns patterns from examples using the interconnected processing units called neurons. Okay, so what you are able to understand here, it is going to learn from the data and useful for non-linear problems, works using the weight and activation function. Okay, so here you are going to have the in ANN, you are going to have the weights and the activation function. Okay, it is going to make use of that, and then it is going to give the required output. Okay, so based on weights and activation function, it is going to train the data, and then it is going to give the output. Okay, and then used in classification, prediction, and recognitions. Okay, so where this ANN is being used, it is used mainly in classification, prediction, and recognition. Okay, so this is the basic ANN architecture which you have to draw for ANN. Okay, so write x1, x2, x3, these are the input values. Then here are the hidden values. Okay, so h1, h2, h3, and these all inputs are connected to all hidden values. Okay, all hidden datas. So this x1 is connected to h1, h2, and as well as to h3. Similarly, x3 is connected to h1, h2, and h3 values. Similarly, for x3, h1, h2, and h3, it is linked to x3. Okay, so this input value has been connected to each of the hidden data. And then at the end, this hidden value, okay, it is going to make use of weights as well as the activation function, and then it is going to give the output, okay, required output. Okay, and next what you have to remember is it is being used mainly for the classification, prediction, and recognition. Okay, next is biological neuron versus artificial neuron. Okay, so this how this ANN concept was inspired. Okay, how this ANN was introduced. Okay, it was being introduced or inspired by the biological neuron. Okay, where a human brain, okay, has the biological neuron, how it works, okay, in a human body. Okay, using that concept only the ANN was been introduced. Okay, that you have to tell or explain. Okay, in sentence you have to write this. Okay, how it ANN came to and picture. Okay, so using the traditional okay, human body which has the neuron, how it works, okay, in the body, that using that concept, how ANN was introduced is been asked, right? So you have to write using the human body biological neuron. Okay, so how it works now, using that concept only the ANN was been introduced. Okay, so here in biological neuron you are having the dendrites, okay, cell bodies, and then axon, and then synapse. Okay, so next here in the ANN you are having the input values, okay, which is going to act as the dendrites, okay, in the ANN, and then you have the summation, or you can call it as a sum, okay, and then you have the activation function, okay, and then followed by the up. Okay, so weights plus bias, sum, activation, and then output. So these keywords you just remember for the end. And for biological neuron, remember these keywords. Dendrites, cell body is nothing but the sum, and then axon you have, okay, which can you can call it as for the activation function, and then synapse is nothing but the output. Okay, so this is how you have to remember the topic for the biological versus artificial neuron. Okay, next you have again the artificial neuron model. Okay, so how what are the steps? Okay, how the mathematical model has been introduced for the ANN. So this is the form. Okay, net equals to, okay, activation function equals to how it is going to calculate weight. W stands for weight and X is the input value. So W1 into X1 plus W2 X2 plus, okay, followed by WN XN plus B. Okay, so next, so you have to indicate, okay, what this W indicates. It is the connection weights, okay, and X are the input values, and B is the bias, and then F is for the activation function. Okay, so this F is the activation function. Okay, next common activation function. Okay, step you have sigmoid. Okay, so these are being used. Okay, sigmoid function is being used, RELO is being used, TANH and softmax. Okay, this common activation function is being used. So this you have to remember. Okay, so which is the purpose, which adds on non-linearity, so the ANN can learn the complex patterns. Okay, so this thing you can, okay, this is the picture. If you watch this video and if you are preparing for the last minute, if you remember this much, you can go and write it definitely, right? So yeah, next is perceptron. I'm just trying to make it as easy as possible. Okay, I know that there are n number of notes available, n number of videos available, but here what students get confused that which study material to refer, okay, what to read, and from where to start, right? So just go through module wise one by one to the videos. In the videos, I have already, along with the question in the PPT itself, I'm including the points, which points you have to remember. At least those points you try to remember and write it on the exam. Okay, you can just elaborate it. Yeah, so that's it. Next here for perceptron model. This is the model which you have, this is the diagram which you have to remember for the perceptron model. Okay, input values you are going to have. Along with input values, you are going to have the weights plus bias. Okay, bias value B. Okay, these input x1, x2, x3 are the input values, weights, w1, w2, and w3 are the weights, and then weighted sum you are going to have, okay, which is denoted as summation. Okay, so write down the formula plus bias value you are going to have for the perceptron model, right? So, okay, and then it is going to be followed by the activation function, okay, and then followed by the y cap, which is going to be the output. So this is the diagram for that, clean and neat diagram for your exam. And then y cap is equals to 1 if net this function, okay, if activation function is greater than equal to threshold value, okay, otherwise it is going to be 0. Okay, if y is equals to 1, okay, when the activation function is greater than equal to this threshold, otherwise it is going to be 0. Okay, next, perceptron learning rule. So this is the learning rule, okay, formula, mathematical formula which you have to remember. What it denotes: t equals to target output, y is equals to predicted output, and error equals to t minus y, right? So very easy to remember, right? So you are going to have the wi, okay, weighted new. So how you are going to calculate the new value for the weighted? It is nothing but old weight value plus, okay, learning rate of, okay, plus learning rate of, okay, this denotes the learning rate, so of t minus y. So t is target output and y is predicted output. So n of, okay, mu of t minus y of x1. So this x, I have already told you, x denotes the input values, right? So this was to calculate the new weighted value. And now how you're going to calculate the bias value? So b of new equals to b of old plus learning rate of t minus y. So in weighted you are including the x value, which is the input value. That's it. Okay, rest is same only. Okay, in weighted you are including the input values. For bias you are not including it. Okay, so just remember this. Okay, last minute, if you, even if you remember this, it is easy for you to write in the exam, right? That is what they are going to check. Okay, and just once you write the formula, next you just write what w indicates, okay, and what x indicates, okay, right, those things in the sentence. That is how you are going to elaborate the answer, right? That is how you can make your answers lengthy. Okay, next is algorithm steps. So initialize the weights and bias, and for each training sample calculate the net. So net is nothing but the activation function, and then apply the activation function. Okay, next calculate the error. So how you are going to calculate the error? It is t minus y. So what t indicates? Target output minus predicted output. Okay, so target output minus predicted output. And the fifth one is update the weights and bias. So how you are going to update the weights and bias? You can just write this thing. Okay, new value and bias value. Though using the formula, you're going to update the weights and bias, and then repeat until error is reduced. Okay, so you have to repeat the steps until the errors has been reduced. Clear? Very easy, right? Next is types of artificial neural networks. So single layer feed forward, multi-layer feed forward, recurrent neural network, and convolutional neural network. These are the four types, okay, for ANN. Okay, this names you have to remember. First one is single layer, second is multi-layer, and then comes recurrent, and then convolutional neural. Okay, CNN you can remember, right? Convolutional neural network. If you remember single, then multi-layer also you'll be able to remember, right? And then comes the recurrent neural network. Okay, so input directly connects to the output, okay, and whereas in multi-layer one or more hidden layers are there. Okay, so here you are going to have one or more hidden layers, whereas in recurrent neural networks feedback connections or sequence data has been happening. Okay, and in the convolutional network the image and spatial pattern learning has been done. Okay, image and spatial pattern learning has been done. Next is ANN applications plus merits plus challenges. So Here you can see where it is being used: ANN, image recognition, okay, so speech recognition, medical diagnosis, forecasting, fraud detection. Advantages are, okay, learn complex patterns, handles noisy data, adaptive learning, good generalization, and then comes the challenge. Okay, so challenges is it needs large data, training time is high, and then black box nature, and then overfitting. So these you can just remember in the last moment, right? So I have included, so you can just note it down and just remember this and just write it in your exam. Eighth is introduction to the clustering. So here clustering groups objects so that objects is in the same clusters are similar. So here you have cluster A and cluster B. So this pink dots belong to cluster B and this blue dots belongs to the okay. So these dots are nothing but the data. Okay. So this indicates the data. So which data belongs to which class is what? Okay, in the similar class, okay, similar data should be there, and this class similar to those individual data, it should be relatable to each other. Okay, so object in different clusters are dissimilar. No class labels are required. Use in customer segmentation, document grouping, and image segmentation. Okay, for example, real time I'll just say, okay, so that you will be able to easily able to remember. Okay, so real time example, if I take, when I talk about, let's say I'm talking about fruits data. So in fruits data, what I'm going to have, fruits name. Okay, for example, I'm having data called apple, mango, banana. Okay, so papaya, pineapple. So these are the fruits data, right? So if I'm talking about fruits data, okay, and there is another data where I'm talking about chocolates. Okay, so I have dairy milk, milky bar, okay, and munch, Kit Kat. Okay, so I'm having chocolates data and I'm having a fruits data. So what I'm saying, if I am trying to divide the data into a cluster, so all the fruits data which I just now mentioned, it will be in the cluster A. Okay, so in cluster A, if you are having Kit Kat, okay, pink color data, so that is a dissimilar data. That data does not belong to the cluster A, it belongs to the cluster B. Okay, so in the cluster B, I'm going to have all the chocolates data, which is dairy milk, munch, Kit Kat, okay, milky bar. So it belongs to cluster B. Okay, so chocolates data can't be in cluster A. Okay, it will become dissimilar data, it does not belong to the cluster A, and fruits data cannot be in the cluster. Okay, as simple as that. Okay, so similar data will belong to the that particular cluster. Okay, next is proximity measures. Here you have Euclidean distance, Manhattan distance, okay, Minkowski distance, and then cosine similarity. Okay, so remember this keywords: Euclidean distance, Manhattan distance, okay, Minkowski distance, and cosine similarity. Okay, so these names you have to remember. Okay, these are the researchers' names. Okay, so remember Euclidean, Manhattan, okay, Minkowski, and cosine. Okay, so what Euclidean distance is going to measure? It is going to measure the straight line distance, most common. Okay, it is used to measure the straight line distance, which is most common. Manhattan distance is the sum of absolute differences. Okay, so this is for the sum of absolute differences. Minkowski distance is going to be used for general form of the distance measure. Okay, it is being used for the general form of the distance measure. Okay, and for cosine similarity, it is majorly used for the angle based similarity for the text vectors. Okay, angle based similarity for the text vectors. Okay, so remember this researcher's name, or the scientist name, which is Euclidean, Manhattan, okay, Minkowski, and the cosine. Okay, an important note: always normalize features before distance based clustering. Okay, so it was for the proximity measures, okay, which is in the clustering concept. Next, you have two approaches. Okay, one is agglomerate, bottom up merging, and then divisive, which is the top down splitting. Okay, so bottom approach you have, okay, two approaches you have, which is bottom up approach and top down approach. Okay, so bottom up approach is also called as agglomerative. Okay, and top down approach is also called as divisive. Okay, result is shown using the dendrogram. Okay, so this is the dendrogram. So this dendrogram you can show in the exam, and no need to predefine the k in the advance. Okay, so two approaches you have in the hierarchical clustering. One is bottom up, and then second approach is top down. So bottom up is also called agglomerative, and top down is also called as divisive, and you can show this dendrogram diagram. Okay, for the hierarchical clustering. Next is K-means algorithm. So choose the number of clusters K. Okay, initialize K centroids. This is covered in the unit 3, I guess. Okay, see in one of the unit this K-means algorithm has been covered. Okay, so there I have explained what is K-means algorithm and how you are going to find out the. Okay, so this clusters, it is here you have this cluster and this, right? So in this cluster, okay, it is going to choose the centroid. Okay, once it choose the centroid, based on that centroid, it is going to calculate the mean value. Okay, repeat until the centroid do not change. Okay, then it for the test data, now it is going to recognize whether the test data will belong to this cluster or this cluster. Okay, so that is how it K-means clustering works. Okay, next question is density based clustering. This is the core idea, and these terms you have to remember for density based clustering. Okay, 12th question, and 13th is grid based clustering. Here again you have steps. Okay, divide data space into cells, then calculate density of each cells, and then third is remove the low density cells, and fourth is merge adjacent dense cells, and then fifth is form final clusters. Okay, so remember these points along with the diagram grid view we can show, and then dense cells clusters. Okay, these clusters you can show for grid based. Okay, next is comparing clustering methods. Okay, so yeah, this is the questions. Okay, for ANN definition, biological neuron diagram, ANN perceptron diagram, learning rule, application plus advantages, disadvantages or limitations, and clustering. Okay, definition and need, proximity measures. Okay, where you are going to have the formulas. Okay, I told about Euclidean, right? Euclidean marathon. Okay, those your distance measure, how it has been calculated, that you have to remember. And then algorithm steps for clustering, clean diagram. Okay, key means clustering, grid clustering. Okay, grid based clustering and density based clustering you should know. Okay, and then advantages and limitations. Okay, so these are the formulas which you can remember. Okay, for an ANN, Euclidean distance, K-means, objectives, and perceptron update. Okay, revise this before the exam. Last minute revision order. Okay, you can take the screenshot of it, and when you are revising it, you can just go in this flow. Okay, so that it will be easy for you to remember. So yeah, this is the last slide. So that's it for this video, and see you in the next video where we are going to discuss. Okay, and if you want notes for this module, okay, so you have to visit the website called vtusmartprep.com, where you are going to sign up. Okay, once you sign up, you are going to get the confirmation mail, and once you confirm it, then you will be able to sign in. And once you sign in, you can select the department, and right now only for machine learning I have uploaded the notes. The rest of the subject I will try to upload, okay, for your upcoming exam. And that's it. So study well. Okay, so tomorrow you have the exam, and also I'm going to make a video. Okay, so tomorrow you have exam, I guess, at 2 o'clock, but at the night only I'll try to upload the video for the problems. Okay, module wise, I'll make the problem from module one, which are the problems. Okay, for module two, which are the numerical problems. I will make a short video, okay, where I will share the tricks and formulas which you have to remember. Very easy trick I will share that. Okay, so till then you just cover the theory part and problems. I will make the video, okay, recorded, and by the end of the day I'll just post it, and that also you can watch, okay, so that if numerical is being asked, you should not lose marks anywhere, right? So and there I'm going to share it in very very easy and last minute preparation, what all things to remember for the numericals in easy way, easy tricks where I will share. So till that time you just read the theory question. Okay, and I know that today RCB versus GT match is that. I know many students will watch match, and some students who are really dedicated, they are going to study, but still once match is over they have to study, right? So after 11 o'clock they will start studying. So watch this last minute preparation. Okay, so in PPT itself I have mentioned the question and answer. So that's it for this video, and see you in the next, where I'm going to share the numerical problems. Thank you. Bye, and all the best.